Hello everyone, my name is Ashfaq Ahmed and I work in the field of structural biology and bioinformatics. Today we are going to cover a topic that can be called how to analyze and compare properties of the top compounds. It is technically part 12 of the series Computer-Aided Drug Designing. I rated this is the most interesting video of the series. Why? I'm sure most of you will like it. Okay. So to start this video formally, first I want to put a scenario in front of you and it will help you to understand this tutorial in a broader view. Assume you have done all the things and tested some 100 compounds. For example, just assume you have done the Kimball part, you have done the filtration part, then you have come to the clustering part, then you perform the artificial neural network part, and then finally you come to the docking part and you did docking. Let's say you dock 100 compounds. Just for example, it's not compulsory, but let's say you dock 100 compounds. Now, it is a fact that you will get some top hits. There will be some compounds that you will call it top hits. Normally, those compounds which showed the better binding against your target. So let's say you want to include the comparison of your top binders of, or you can say the comparison of the top ligands in your thesis, in your publication. But why you will compare that? This is a question. So the answer is because at times the reviewer asked you like just to compare your top 20 or top 30 during the manuscript submission or manuscript publication process, or sometime you itself want to just compare the top compounds and show few of them in the manuscript or then in the thesis, but overall you want to compare some compounds. Let's say you want to compare top 10, top 20, top 30, or it's up to you, you receive. So this notebook is for you and this tutorial will do magic for you. So let's start how we can compare or what we can compare or what we will achieve. So let's start. So as usual, we will work on in the notebook, and I'm sure most of you will be aware that how to access this notebook or how to access this repository on the GitHub. But still, as usual, I will drop this link in the description section of the video. So once you get this kind of panel, then you need to click here, cat underscore project. Once you click here, then you need to come to part 12. It should be somewhere uh, here. Detect properties of smileys, part 12. If you are confusing in the name, so just remember part 12. The video title is also part 12. So here you can see. So just click here. Now, first you need to connect here. And once you are connected, then I will start this installation of something. Okay, we will do it later on. Okay, so what is this notebook or this tutorial is all about? It will give you some state-of-the-art visualization. It will perform a tremendous kind of comparison. And what we will do? We will use smileys of the top compounds. And if you are new to this series, so I think you need to watch my other videos so you will know what are smileys. These are the linear representation of the chemical compounds. So those people who are following this series, they know what I'm talking about. So you will use compounds, the smileys of different compounds, and we will predict some properties in a better way. Okay. If you can read here, if you are using single input, let's say you have one compound or two compound, you have one compound, you just want to check its properties, then just insert your smiley here or the name here and just run this cell. But this notebook is not basically designed to check the single smiley, so I'm sure you will not be interested in this section, so skip it. Okay, now for using list of smileys. In the introduction part of this video, I just said that you assume you have top 10, you have top 30, you have top 20. So what you will need just to copy your smileys here in this orange section. Okay, but I would suggest just copy one by one. I know it may take maybe 1 hour or 30 minutes of you, but once you see the result of this section, then you will not get bored and you will do it. Okay, so ibuprofen or aspirin and lovastatin and acetaminophen. I will use all these four smileys in this tutorial section, but you can increase it. How to increase it? Let's say you have inserted four, but you have five. So just after this comma, enter, and then you can, let's say, you can write another one following this fashion, or like these two I don't know. I said I always call it double dots. So following these two double dots here or here. So this way you can drop the list of your compounds here. Don't worry, I know the top compounds will not be so many, so it will not be so tedious work. And just play here, uh, run the script. Okay. Uh, it says some error, so maybe I made some mistake. Let's see what it is saying. Smileys is not defined. Okay, so then you will also need to run the script. I forgot. Just run it without anything. It's okay. Okay, now it is fine. Now we will install some dependencies and we will install smileys to properties. It's a kind of directory present on the GitHub, so we will clone it directly. Click here. Then after that, we will install the RDKit and program name is moles2grid. Okay, you can find out these papers if you are using this tutorial. So, of course, you will need to cite them. Okay, then here we will install chemprop and the double is equal to sign. This is actually the version 1.2 5.2, and then we will install Soltranit. This is another package. Okay, and then we will install some this transformer, sentence piece, and T5X. So we will also do some model training and quickly. That will not be so much time consuming. So I'm going to pause this just to complete this installation. So we'll come back. Remember, these running these four cells may take 2 to 2.5 minutes, or maybe three if your internet connection is on the slower side. Okay, then we will convert these information which you have provided into a data frame, and we will name it like the first column compound, the second will be smileys. Okay, now interest you can see these four compounds along with their smileys. Now optionally we also want to use the database or the information of the FDA approved drug as input to recalculate normal ranges. Okay, here I also want to tell you, let's say you have top 20 compounds. So if you run this uh, before selection of the compounds, then you can also, let's say the top one is not in the range of FDA approved drug, but top three falls in the range of approved drug. So I would suggest go with top three. But okay, so here what we are doing, we have included some drugs or the list of some drugs which are FDA approved. Now, we will use a program or a package Soltranet, and we will predict the solubility. We also call it log S. Okay, so here we clicked. We will run this cell, and it will collect, or it will calculate. Oh, sorry, not collect. It will calculate only the log S. You can see this, you will get the log S value of the compound. Okay, now here we will run this cell, and we will predict some captions with smileys to captions. What does it mean? It actually means we are building a kind of file with tokenizers or a transformer to to and they to be used further in analysis. You will understand once we run this. Okay. Now we optionally, this is not must, but it's optional, but you can use it. We will import some data sets from deep chem data, and we will import some classification data sets, FDA approved data sets, some hydration data sets, and some solubility ESOL predicted log solubility data sets, some blood-brain barrier BBB penetration data sets. We will import these data set directly, and we will, because we want to compare our compounds, our top hits, with some available data, and to receive a meaningful result. Okay, we will also import some data set from molecular net. Here we did, and also, okay, now we will run some chemprop model on the smileys, chemical properties model actually. Okay, so its name is chemprop. We have already installed this program. Okay, it will calculate such kind of things, and it may takes probably should not take so longer, 1 to 2 minutes maybe. So let me pause this session again, not to waste your further time. Okay, welcome back. It took almost little more than 1 minute. So we have four compounds. So in your case, if you have 10, 20, or maybe 100, so just have a cup of coffee to wait for this section. Okay, okay, I will clear it. Doesn't matter. Now we done all the things, and now we will create some plots to analyze this data. So we will create two kinds of plots. One will be the strip plot, one will be the bar plot. So, and both these kind of plots will show similar kind of data. So it's up to you to consider or to keep strip plot in your thesis or to keep bar plot in your thesis. It's up to you. By the way, I like strip plot the most. Okay, and uh, in both of these plots, you will see some dotted lines, and the dotted lines will show the boundaries of the FDA approved drugs. So your drugs and the properties, your compounds and their properties will be compared with the FDA approved, also with each other. Okay. Okay. What kind of properties we will test? In solubility, we will test water solubility, also called ESOL. Equal solubility, that is also called log S. Hydration free energy, or BBB, blood brain barrier. Okay. And it relates, or this term means it relates with the permeability or the absorption, I would say, of the drug. Okay. Now, for this is the toxicity panel. So I would suggest to read about this, because if I go for explaining each and everything, so most of them are protein names, are protein abbreviations. So I'm afraid I will go so longer. So that's why. Okay, FDA approved. I told you there will be for the FDA approved, and some bioassay subsets from some bioassay. So it's okay. If you need it, just read it. You will find much more literature on this toxicity and this MUV. So okay, now we will run these cells and magic will start. Okay, here we will plot the bar chart. Okay, now, okay, this is not a single plot. You can see this figure. So there are many plots. So we had only four compounds. Let's see, one, two, three, four. So you can see from the different color, the solubility chart explains log S, water solubility, and hydration free energy. Okay, so you can see this is the lower scale. You can see these bar lines or these dotted lines. This is actually the boundaries of the FDA molecule. Like I would say, in water solubility, this red one, it actually acetaminophen is slightly lower. It's not very significantly, but slightly lower in solubility. But in hydration free energy, it's leading the way. The same way, now we are going to the second plot. This is about the blood-brain barrier. These two lines are the FDA approved, and this is the status of these four molecules. Now, on toxicity, these four color, you can see four colors. So on toxicity, about the NR and androgen and LBD, ligand bind domain of androgen, etc., etc., and go for it and its role on each and every toxicity panel. Okay, I would suggest to read it. Okay, on the FDA approved panel, all fours are almost equivalent to the FDA approved. But remember, I'm using the FDA approved drugs. Ibuprofen is commonly available. Aspirin is the choice of drug in cardiovascular diseases and many things. And loastatin also an FDA approved, and acetaminophen is also, I think, an FDA approved. So that's why you are seeing this panel. All of them are equivalent to FDA approved drug. But in your case, who knows? So it will help you to show your data or to show much more analysis. Also, just to decide, like you got top 20. So now from top 20, with which one you need to go for simulation or other things. Okay. Now, you will, you for sure will want the PNG of this plot. So just click here and you will see some PNG data here. You can see this is the solubility PNG. Let me refresh it. Okay. So you can see this is the toxicity PNG, solubility PNG. Okay, let me try. I will just copy the download the solubility PNG. Just want to show you that yes, it's working. You can see this is the solubility PNG figure, and you can use it or you can tweak. This is the toxicity PNG. This is the FDA approval PNG, and you can search. Uh, this is okay. So now we will generate some strip plot. Remember, I told you in the start that both these plots show the same data. The strip plot will also show the same data, but in some advanced kind of manner. So, by the way, I told you I like the strip plot the most. Okay, first run this. It will generate some strip plot. Okay, now this is the solubility panel on the strip plot. This is the log A's water solubility and hydration free energy. Each dot, four dots for this, four dots for this, and four dots for this. And each dot represents, each different color dot actually represents each, how to say, each feature. So on log S panel, the loastatin is slightly lower. You can see here almost it's uh, near to -6, and these are the FDA things. So these lines, okay, the blood-brain barrier, the NAR, and all those things, and the FDA approved, all of them are lies. So why are you seeing these two dots? Because the two dots are below these two dots. So that's why, because we also studied these properties here. So we know that they are almost equivalent to each other. Okay. So now if you want to save this figure also, so you have to click this, and all these figure will be stored there with the name combined plot PNG. If you don't like this name, just change it here. Run it. Now you must have this plot here. Now let me download it to see it's working or not. Okay, you can see this is the FDA approved plot, this is the toxicity plot, and this is the blood-brain barrier, and this is the solubility plot. Okay, now final interesting thing. Uh, Now you want to print picture of all your top compounds in a beautiful way. So just click here. Because I had used four compounds, so I got four compounds. This is ibuprofen, this is the aspirin, this is the loastatin, and this one is the acetaminophen. So if you want to search some specific thing or smarts, whatever you can. Otherwise, you will have this chart or this list for all your compounds you tested in this notebook. Okay, because we are viewing this thing using a different library, so we call it IPython display. So this figure will be saved in HTML. So if you want to convert it to the PNG, for sure you can. There are too many things converting an HTML file to PNG. What is the difference in HTML file and PNG? HTML will be open in your browser. So, okay, you click here and the file name will be moles to grid display.html. It should be here now. If not, you just refresh it. It will come here. Should be here. Now, download. Okay, wait, it's downloading. Okay, it's done. Now I'm opening it. Okay, you can see. So this is the figure. Because I have used four, so I can see four things. Maybe you will use 10, 20 compounds, so you will have very beautiful figure for your thesis or manuscript. Okay. If you want to download this data in a CSV file, just run this. It will download the df.smileys into TSV. Then you need to search it like how to open the TSV file. It normally I just gave you a indication that you can open it in the Excel, Microsoft Excel, but still you also need to search it. Okay, but I'm sure you can use this file as a supplementary material if someone likes or someone want to see that what is your actual data from where you did all this plotting. So I hope you like this tutorial and I have tried my best to cover it in a good way. And I have also shared you that how can you use this tutorial in your research? So one last thing I just want to share with you guys, just kind of complain. On my YouTube channel, I'm observing or I'm looking the statistics. So you will be surprised to see that those people who are watching my videos, among them 86% are not subscriber. So just a humble request, if you are liking my work, if you want me to continue, please just subscribe. I'm not asking you to turn on the bell notification option. Normally, I also don't request you guys to subscribe just like other people from the start of the video. They will start their video or in the middle they will pause it and will say just subscribe. So I'm not doing all those tricks, or you can say I'm not good in those tricks on such kinds of tricks. But if you are really liking my videos, then do subscription. I just request. And if you don't like, so it's okay. You can watch it. That was just a request. Okay, so have good times, and if you are enjoying my video, thumbs up, stay happy, and if you want me to provide some suggestion, you can. Okay, thank you so much. Bye bye, stay happy.